Hello and welcome back everyone. In today's lecture we will learn all about character, a second fundamental data type called character. Char data type, also known as character data type, is the most fundamental data type in C programming language. It only stores one character and uses 1 bytes of memory to do so. There are several encoding schemes available for character encoding. However, the ASCII encoding scheme is one of the most widely used. This is the ASCII table containing information about the ASCII encoding scheme. As you can see, there are some characters that are not printable and some of the characters are printable characters. The non-printable characters are the control characters and the printable ones are the characters that you can print on the screen. ASCII uses 7 bits to encode characters. Therefore, we are available with 128 characters in total. As you can see, this ranges from 0 to 127. That is a total of 128 characters. As I told you, character requires 1 byte to store data. And as we know, 1 byte equal to 8 bits and ASCII requires just 7 bits to represent characters. Therefore, the most significant bits is set to 0. Let's look at how to define and declare characters data type variable. Here you can see I have declared a variable of character data type and assign it a character. And this is the name of the variable. You can name it whatever you want, but in my case it's varchar. However, if it is of the character data type, it can only hold one character at a time. Note down this single quote over here. If you remember, in case of integer data type, we are not putting single quotes, but in case of character data type, we use single quotes. Remember to use single quotation mark. A character variable can only hold one character at a time. Keep in mind that whenever a character value is given to a variable of type char, its ASCII value gets stored. Note the character value. If you give it the whole string, it wouldn't be able to hold it because its size is only 1 byte. Now, this is also not necessary to provide only characters to these variables. You can also give them integer values. As you can see, I have provided a value 65. When we print this value, it will behave like a character. When we attempt to print the content of this variable, we receive a character rather than an integer. And it totally depends on the format specifier you are using. If you use %c, the character value will be displayed. And if you use %d, the integer value or the ASCII value will be displayed. But in this case, it will print characters. Let's see what is the associated character value for this particular decimal value. As we all know, the associated character value for this decimal value 65 is A. That is why the letter A is printed. If you look at the ASCII table, you will notice that A is assigned to decimal value 65. If you enter 65, it is equivalent to entering the character A. Let us now understand why this happened. Because after all, everything is only in bits. Therefore, either you write a character A or value 65. Both are one of the same thing. Because they have the same binary representation, the only difference between a character and an integer is that a character can hold 1 byte of information. On the other hand, an integer can hold either 2 or 4 bytes of information. Both are capable of storing integer value. Both are capable of printing integers. However, it is better to use them as they are meant for. Let's take a look at the size and range of a character data type. A char variable or character variable is 1 byte long. In case of an unsigned character, the range would be from 0 to 255. In case of signed characters, the range would be -128 to 127. This representation comes mainly from the 2's complement representation. Unsigned range is because we have 8 bits of information available with us. Therefore, the maximum value that we would be able to represent 255. In the traditional ASCII character encoding, we have only 7 bits to encode the characters. And the minimum to minimum we have to have is 8 bits. Therefore, 8 bit is totally good. There is one more encoding scheme called extended ASCII encoding scheme to utilize the 8th bit, or you can say MSB bit. So the range is properly utilized in this encoding scheme. As you can see, the range is now 0 to 255 rather than 0 to 127. Note, apart from these English characters, for non-English speakers, we have to represent other language characters as well, like Russian, German, Chinese, etc. For them, other schemes are available. But our concern is traditional ASCII encoding scheme, which cover most of the special symbols as well as English characters and digits that we use in our day-to-day life. And the most of the time, this is sufficient. Therefore, we would not have to worry about as much about the other schemes. Let's move on to the next topic, the distinction between signed and unsigned character. I told you about the signed and unsigned range for characters. However, the fact that we have both signed and unsigned characters is not easy to accept. Unsigned range is fine, but why signed range? Signed range makes sense when we're dealing with integers, because we have actually representing both signed and unsigned integers. But what do negative values do in characters? Are they purchasing additional power for us? Even though we would not require negative value at all. But as we all know, internally everything is form of bits. So we can't restrict ourselves to provide negative value to a character. The question is, what happens when we give it negative value? Consider the extended ASCII table once more to grab this concept. The range of 0 to 127 is the same for both signed and unsigned numbers. The difference is minus 128 to minus 1 in case of signed and minus 128 to 255 in case of unsigned range. Let's write down the 2's complement representation of minus 128 in binary. There are one more important point to note. Here you can see the place value is minus 2 raised to power 7, and that is not the usual case when we are representing a positive value, right? This is minus 2 raised to power 7 to represent the negative 128. We must set this bit to 1 and reset all other bits. Because minus 2 raised to power 7 equals to 128, therefore the setting the specific bit, we will be able to represent minus 128. This is a representation of 2's complement. Always keep in mind that the place value of the most significant bit or MSB bit is always negative. In case of positive numbers, this is simple because the place value is positive. If we set this bit to 1 and clear all other bits, we will represent plus 128. Let us try to represent minus 127. We can represent minus 127 by setting this bit to 1 and this bit to 7. However, if I want to represent the value plus 129, it is also very simple to do so. This is 2 raised to power 7, which is equal to 128, and 2 raised to power 0, which is 1. When we add two values together, we get 128 plus 1 equal to 129. As we can observe, these two values are equal. As we can see, these two values are same. These two values are same as in the previous case. Both minus 128 and plus 128 have the same binary representation. Similarly, the binary representation of minus 127 and plus 129 are the same. If I want to represent minus 126, this is the binary representation, and for plus 123, this is the binary representation. Both are equivalent. This is minus 128 and the rest of the number when we add together equal to plus 127. 128 minus plus 127 equal to minus 1. As a result, we must set this value to 1. If we want to represent plus 255, we must set all these values to 1. But the only difference, as you can see, is the place value. That is why we are getting two different values for the same binary representation. To understand, let's just use this code. If we try to print minus, we get the same result as if we try to print plus. Let's put the code into action. And let's see what character is displayed for this specific value. This would be the character. If you look at the extended ASCII table, the associated character for this particular value is this. Let's give this code a little bit boost. Assume we assign -128 to character var1 and +128 to unsigned character var2. Print both variables. Let's execute this code and see what is the outcome of this particular program, whether they print the same character or not. Yes, they are printing the same character. Therefore, it is verified that -128 and +128 both are the same. Now, let's see this program. In this program, we declare and define character variable and assign this to +129. Let the code speak for itself. This would be the result, -127. So, in case of character variable, negative value will not give you any extra power. Always remember that in the extended ASCII encoding, each negative value is equivalent to some positive value, because after all, everything is binary only. Also, the concept of range exceeding condition for character is similar to integer, which we studied in the previous lecture. Therefore, it is not worth mentioning each and every point once again. You can refer to the previous lecture and relate the concept accordingly if you want. I will put the link in the video description. Okay friends, that's it for now. See you in the next one. Bye bye.